I'm David Coover, and I'm with the REACH program. I'm an intern here at the Division of Water Quality Chem Lab, and today I'm in volatiles, which is testing for volatile organics in water samples. And we use this machine. This is the FID GC, which is flame ionization detector, gas chromatography. And what it does is it calculates retention times, and each retention time corresponds to a different compound in the water. And exactly that right time is when the compounds will set off by this machine. And you can calculate how much is in the water sample by reading the response of the chromatogram. But I'll show you that in a second. This right here is it's called the Volatile. It is the robotic arm right here, which will pick up and grab samples like this. This is the example we already used today. First, I would check the top here, see if the septa is not broken or anything like that. And then I would check the back of this for any headspace, but you can't tell right now. So I would basically set this up, and I would tell the computer over there which vials to pick up and which to sample. But first, before any of that, I need to run what's called a daily standard. And the daily standard is to make sure that my machines are working properly and reading correctly. So I would take this vial of water, which we got from behind you, and this is some daily standard, working daily standard. And I would take some of this out of here, 25 micrograms out of here, and put it into the vial. But we've already done that. So I'm just going to follow the path of what a sample would go through on a normal day. So Volatile would pick this up, take it over to the elevator, which is back here, and then it would go up to this needle and take out 10 milliliters. And these 3 vials here, only one of them we're actually going to use. It has surrogate in it, and the surrogate's purpose is it's away from all the other compounds. Its retention time is away from all the other compounds. It's going to be at the end of the chromatogram, and it's basically for good recovery is what we're looking for. That also means that our machines are working properly. So after it goes through here, it's going to go behind through these thermal wiring, or thermal heated system there, wiring. And it'll come over to this machine. This machine is the purge and trap concentrator, and the sample will go into this contraption here, and it's going to bubble with helium. And helium is the carrier gas. And the carrier gas is going to bubble the sample and heat it so that all the compounds, all the volatile compounds in it will hopefully be trapped onto this trap up here, which you can't see. And that takes some time. That takes a few minutes or so. And once it is all purged and on the trap, the purge and trap, it will stay here, and then this machine will kick on. It'll go behind there, you can't see, and then come through here, and it will heat up. It will start at an initial temperature right here, and then heat up through the ramping stage, about 20 degrees Celsius per minute. And hopefully while that's happening, all the compounds are now on a column. Sorry, I didn't mention that. They're now on a column, and while it's heating up, hopefully it will set off those organic compounds at specific times. Like you see here, this is a daily standard we ran earlier today. You can see all these peaks on this graph here, and down here is time, and up here is the response. So if you look, you can see some of the first ones are like methyl chlorides up at the beginning, and way back there is our surrogate. So each one of these peaks is a different compound, and we screen over here for about 48.